Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clarke and this is episode number 43. And today is going to be another solo episode, and this time I'm going to try to demystify Docker. Now I'm going to cover an awful lot in this episode, from the basics of what a container is, and then building upon that, explaining about images, how you build your own, how containers are run in production, what Docker composes, and also various use cases for containers. Now, if you're new to these concepts, I'm aware this will be an awful lot to take in and might require listening back a few times. I'd recommend listening through once, then having a play around with Docker locally and trying out a few of the Docker commands we talk about. Then come back and re-listen, and slowly these concepts should hopefully start to click. It's definitely worth the investment learning Docker though. There are so many different use cases, and hopefully this episode will help you start that journey. Before we do delve into the land of Docker though, don't forget that this podcast now has its very own Slack channel. If you head over to the website unhandledexceptionpodcast.com, you'll see a big shiny Slack link there. And also a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. Okay, Docker. So let's start by explaining some of the different terms. Let's start with containers. What are containers? So in one way, you can think of them as very lightweight virtual machines. You spin them up. They have a file system. You can open a command line in a shell in the container and run commands on it. There are Linux and Windows variants, and you can create snapshot images from them. And we'll talk more about these images in this episode. However, there are quite a few differences from VMs too. And one big one, which I see a lot of people get confused about initially, is that a container usually revolves around just one process. So when a container starts, it has this main process that gets started, which is typically the thing you're running. For example, a website or an API or a console application. And when that process ends, whether that be the app just completing cleanly after finishing its work, or an unhandled exception gets thrown, however that process ends, then the container will also end. The lifetime of the container is the lifetime of that process. So imagine you have an architecture with a web front end, two different backend APIs, maybe a database, a Redis cache, and just say you wanted to run all of those things in containers. So personally, I would put the databases in PaaS, the cloud platform as a service services, which are managed and not part of containers. But let's just say you wanted to run all of these things in containers. Then each of those things would have its own separate container. So the website would have its own. The two different APIs would have their own individual containers. Whereas with a VM, you might have multiple things running on that same VM. Containers are just about one thing. That's one thing I see people get confused about. They think you can put more than one thing in a container, where a container is about one thing. It's one of your APIs, whatever it is. A particular web app goes in a container. If you've got a console app that's listening to messages off a message queue, that would be its own container. So each service or whatever it is has its own container. Another difference from VMs is that containers are super quick to spin up. A VM might take a minute or two to spin up before they're usable. Containers typically take seconds. So hopefully that gives you an idea of what a container is for. I'm not going to go into the implementation details here. Windows and Linux containers are implemented in quite different ways, but that's out of the scope of this episode, and you don't really need to know how they're implemented to use them. But if you're interested, I'd recommend reading up on Linux C groups and namespaces. It's all quite interesting how Linux leverages them to make containers possible. But again, this is out of scope of this episode. So what about an image? A container is a running instance, and an image is a snapshot that sits on the file system. And you can create containers from images. And you can create multiple containers from an image. So an image is a fixed thing on the file system. This is how you share your images, how you can use third-party images, you can build your own. And then containers are instances of an image. As I say, you can build your own, and if you want to share it with other people, you typically push your image to what's called a container registry, so that other people, including your hosting environments, can then pull those images down and create containers from them. So images play a big role in deploying and sharing your application or service. So again, an image is a snapshot, it's not a running instance. A container is an instance of an image. I'll dig a bit more into images shortly, once we've covered a few other things first. So let's talk a bit about these container registries I've just mentioned. The ones where if you build your own image, you can push those images to a container registry. These are pretty much just hosting providers for images. You can create your own private container registries. Most cloud providers have managed private container registries that you can spin up. The most well-known, though, and also the default container registry, is called Docker Hub. And if you go to hub.docker.com, you can browse all the images there. And at the time of writing, you'll have nearly 9 million images to choose from. And if you have Docker installed, you can run them by literally just typing docker run followed by the image name. And doing that will automatically pull the image down to your machine and create a container from it. It's really insane how powerful it is and easy it is to use. So if I have a brand new machine, it only has Docker installed, and I want to run, for example, MySQL, I can literally just type docker run MySQL. So maybe some examples of common images: Redis, MySQL, SQL Server, RabbitMQ, Elasticsearch, and obviously nearly 9 million other things. So there's a lot of stuff you can just spin up very, very easily. So hopefully you're getting an idea of why you might want to use them. But here's some more reasons. Consistency. Once you build your image, and again, I'll talk more about building images in a bit, it's the same image, the same file system inside the image for each container you create from that image. So me spinning up a container locally is the same as a colleague spinning up a container from the same image, and is the same as the container being spun up in production or any other environment. They're the same binaries. Another advantage is dependencies don't need to be installed. So for example, I mentioned before about spinning up SQL Server or MySQL. I can spin up those containers, I can use them locally, and I don't have to actually install those things. I also find this useful in CI/CD pipelines like Azure DevOps or GitHub Actions. To build my app, the only thing the build agent needs to have installed is Docker. It doesn't need to have the latest .NET SDK or the latest Node or whatever my app uses, because those are baked into the images. I think locally, the biggest use case I use it locally is, as I mentioned before, if I need to spin up a database or something. I don't have SQL Server installed anymore on my machine, or RabbitMQ, or any Azure storage emulators. I use Docker for them all. For example, in one application I work on where I use all of those things, I literally just run Docker Compose up, and all of those 3 services spin up in seconds. A new dev into the team, Git clones the repository, Docker Compose up, they have those running as well. So it's great for onboarding too. And then at the end of the day, I can run Docker Compose down, and they're gone. And I'll talk more about Docker Compose in a bit. Another brilliant use case is for integration tests. You can run third-party services, as I mentioned before, for example, the database, using Docker Compose up. Then you can run your integration tests against them. So instead of using things like in-memory entity framework implementations, you can very easily run your integration tests against your real code talking to a real database that you've spun up with Docker Compose up. When I'm starting work at the start of a day on a project, I would do a Docker Compose up, it spins up all those things, then I can run my integration tests whenever I feel like it. Then at the end of the day, I'll do a Docker Compose down. And in CI/CD on Azure DevOps or GitHub Actions, they can do exactly the same thing. This has transformed the way I write tests, to be honest. So next, let's talk about how you interact with Docker. And the primary method is via the command line using the Docker CLI. There are GUIs available. For example, when you install Docker Desktop, that comes with a GUI. But I'd recommend that everyone at least feel comfortable with the Docker CLI. So let's talk about some of the common commands you might want to use. One might be docker pull. Now, you might not actually use this that regularly because some of the other commands do this explicitly, but I thought this one was worth mentioning first. And this just pulls down the image from the container registry to the machine you're running docker pull on. So this image is now cached, ready to use. And by use, I mean create containers from it. Another command you'll use, which will be more often, is docker run. Now this is what will create a new container from the specified image. And if the image doesn't already exist locally, as in it's not already cached locally, then it'll automatically try and pull that image before running it. So if, for example, I had a completely fresh machine with just Docker installed, and I ran docker run RabbitMQ, then it would automatically pull that image down from Docker Hub and create a container from it. Some other commands, docker stop, this stops a running container. Docker start, this starts a stopped container. So you can start and stop them. Another one, docker ps, this lists all the running containers, and you can add -a to tell it to include stop containers in that list. Docker exec, this is a good one because this allows you to get a shell, a command line, inside a running container. So if it's a Linux container, you'll probably get a bash shell where you can type what you would normally run on a bash shell. Docker commit. So you probably won't use this very often, but you can use this to create a new image from a running container. As I say, you'll probably rarely use this, but it's worth remembering that whilst you normally take an existing image and create containers from it, you can create images from containers too. In fact, that's actually what's happening behind the scenes when you do a Docker build, which we'll talk about shortly. So I mentioned about Docker Compose. So each of those commands I've just spoken about have all sorts of different arguments. For example, when you do docker run, you'll probably also need to pass in the -p argument to open up a port. P stands for publish. However, I personally prefer to think of it as standing for port. It's easier to remember, P for port. On the command line, when typing docker run, having to type all of those arguments each time, you have to remember them. It can be a bit of a pain, lots of typing. And what if you want to spin up multiple containers? Like I mentioned before, that I quite often would spin up RabbitMQ, SQL Server, Azure Storage Emulator, a few different things. Now this is where Docker Compose comes in, because it allows you to have a YAML file, which you can put in source control. And in that YAML file, you can specify multiple services, which will create containers from each. And the arguments you would have specified within Docker run, you can specify these in the YAML file. So it just means that this is source controlled. Once you have that YAML file, you can just type Docker Compose up. Instead of typing docker run individually, that'll spin up everything that's in the Docker Compose file. So just to take a step back and put that into context, imagine you have a docker compose.yaml file in your project. It contains SQL Server, RabbitMQ, Redis, perhaps even a few of your own microservices. A brand new developer starts on the team with a brand new machine that only has Docker installed. They then clone the source code from Git and run Docker Compose up. Now they have running locally SQL Server, RabbitMQ, Redis, and various of your own microservices running locally just like that. It's pretty powerful. And you can use Docker Compose in production, but I've never done this. I personally prefer to use a container orchestrator tool like Kubernetes, which I'll talk about a little bit in a bit. But I personally just use Docker Compose for local stuff, like I've already mentioned. It's worth pointing out at this point that containers are transient. So if you spin up a database in Docker, the data files are stored inside that container, which obviously isn't what you want for a database. So when creating a container, you can specify something called a volume, which is basically a virtual file or directory in the container pointing to a directory or file outside of the container. So it gets persisted. And the stuff running inside the container, at a very simplistic level, think of it as a symbolic link. When you specify a volume in the docker run command or the docker compose file, that volume can literally just point to a file on your host machine or directory, or it can be more complicated than that. It can point to cloud storage somewhere. So that's how, if you do want to have persisted data, but still use containers, you would lean towards volumes. Right, so let's talk a bit more about images. As already said, images are fixed snapshots that you create containers from. But there's a bit more to it than that. Images consist of layers. So when you build your own Docker image, you always start by specifying a base image to build from. This could be a container OS like Ubuntu, or it could be any other image. For example, if you're building a .NET application, you'll probably base your image off one of the Microsoft .NET images. If you're building a Node app, you'll probably base it off the Node image. And those images in turn will be built on top of other images like Ubuntu, Debian, that kind of thing. And layers are actually even more granular than that, but we'll come to that when we talk about building your own containers with Dockerfiles very, very shortly. One key point to note is that each of these layers is cached. So for example, if I pull two of my images from a container registry, maybe API 1 and API 2, and they're both built on top of a .NET runtime base image, then Docker's not going to try and pull that base image down twice. So you find that because of all this caching, when running containers from images, when building your own images, unless it's the first time you've done it, then it's going to be pretty quick. Okay, so let's dig into Dockerfiles, which is how you build your own images. And these layers that I spoke about might make a little bit more sense as we talk about these Dockerfiles, and you'll see how powerful this caching really is. So a Dockerfile is just a text file with a series of commands. You then build the image by running docker build on the command line against this Dockerfile. The Dockerfile always starts with a line using the from keyword. So the first line will say from followed by some base image name. And this is what I meant earlier when talking about base images. You always build your image on top of an existing image. And when you do docker build, Docker will automatically pull down this base image if you don't already have it cached. Then behind the scenes, when you're doing the build, Docker will create a temporary intermediate container from that base image. You don't actually see this happening, but it's useful to understand this. And the following commands in the Docker file, it'll be running on top of that intermediate container. Each line in the Docker file does start with a keyword, and we've already spoken about this initial from. Another common keyword is run, and this will run any command in this intermediate container. So if we're building a Linux image, run would typically be followed by a bash command, maybe apt get install to install a dependency. Or if you're building a .NET app, .NET publish maybe. You can even run your tests inside your Docker file before doing your .NET publish with run .NET test. So you can see you can just run these arbitrary commands. Now, so I mentioned that this run is happening inside your intermediate container. Every one of these commands will then create a new layer. So effectively creating a snapshot image at each command, and that layer will be cached. So each of these steps in your Docker file will be cached. So the next time you do Docker build, unless it's been invalidated because something's changed, then it won't have to run that command again. It'll just use the cached version. Another common command you'll see in your Docker file is called copy. This allows you to copy files from your host machine into this immediate container. which is obviously required so that you can copy your source code into it so you can build it with, for example, the .NET build command. And the last command you would typically have in your Dockerfile would be entry point. So remember earlier that I said that a container is typically just about one process. When the container starts, that process starts. When that process ends, the container ends. This entry point command specifies what that process will be. So if you're building a .NET app, then the run.NET publish command will create the binaries, the compiled binaries, in the usual place, bin, release, publish folder, as you would typically see if you weren't using Docker, and this entry point command would just specify a path to that. Okay, so technically that's not quite true for .NET, because .NET is just in time compiled at runtime, and you run, especially .NET Core Plus, you then run .NET apps via the .NET command line tool. So in this case, that single process is actually .NET, the .NET command line tool. But you just pass in your compiled DLL as an argument to that, the same way as if you weren't using Docker. So the entry point command might look like entry point.net bin /release .NET 6 /publish /my API.dll. I guess using .NET as an example makes this harder to explain. If you're using a C++ natively compiled app, then the entry point would just reference your compiled exe file. I hope that made sense. So let's just take a step back and put this together. Imagine a Dockerfile with 4 lines of code. I'm obviously greatly simplifying this here, but line 1, from some base image. Let's call this the .NET SDK base image. Line 2, copy ... That's going to copy everything from your host machine into the intermediate container, so the Docker build has your source code. Next line, run.NET publish. Obviously, that's just going to run the command .NET publish, as if you're running it on the command line anyway. Then the last line, entry point.NET, then bin release publish my API.dll. So hopefully you get an idea. I know this is hard to explain over audio, but hopefully you get an idea of the different steps of building an image. You specify your base image, you copy files into it that the build context can use. You would run some commands on it. So commands could be installing stuff that the image needs to have. It could be compilation. It can be whatever you want. It could be running tests. And then you end with an entry point with what the image that you've just built, what that entry point process is going to be when you run a container from that image. Right. So if you're still with me, you probably want to pause and just have a deep breath. I know I do. We are getting there. Another thing that's worth mentioning, though, is something called a Docker build context, which is worth knowing about. When I said that the copy command copies from your host computer where you run the build, that's not entirely true. When you run Docker build, you specify a path, which is normally just the current directory. So you just put dot. So you might do Docker build dot. Docker build will then copy all of the files from that directory into what's called a Docker builds context. And it's this context that the copy command copies from. So it's, in a way, it's kind of invisible to you that it's doing that. It feels like you're just copying it from your host machine. But the reason it does this is because the build might not always be happening on the same machine. So for example, you can actually offload the build to another service, although normally you'd just do it on the same machine. You can also create a Docker ignore file to tell Docker build not to copy certain files or directories into your Docker build context. So for example, if you have a local node modules directory locally, because you've been developing locally, when you do a Docker build, you probably don't want to be copying that massive directory into the context for the Docker build. So a .docker ignore file can help with that. It works very similar to a .git ignore file. So let's just talk a bit more about these layers and caching. Each of the Dockerfile commands I mentioned earlier, like copy, run, etc., they create a new image layer, as I mentioned before. and each of these layers is cached. The cache gets invalidated for a specific layer if something changes. So for example, if I change some code, which I tend to do while I'm coding, then the Docker build context that I mentioned earlier will have changed. So that will invalidate the copy command layer in the Dockerfile and all the commands below it. So that's really useful. What this means is that every time I do a Docker build, it's not having to process every single command each time. So if, for example, you have a run apt get install command near the top of your Dockerfile, then it's not going to have to install that thing every time you change your source code, because that command is already cached because it's higher up the Dockerfile. To take advantage of this cache, I quite often in my Dockerfiles with the copy command, I would copy the CS proj files first. Then I would do a run.net restore, so that command is cached. Then I would copy the rest of the source code in before I do my .NET build. So what this means is that when I change my source files, unless it's the CS proj file, it won't invalidate that .NET restore layer and do a full .NET restore each time I do a Docker build. If you're not following me so far, it might be worth re-listening because it's going to go a little bit deeper now, and we're going to talk about something called multi-stage Dockerfiles. Now what this does, it allows you to have in the Dockerfile the from command that I mentioned before that specifies the base image. It allows you to have multiple from commands. Now before multi-stage Dockerfiles were a thing, one problem was that the base image required to actually build your application tends to be a lot bigger than the base image you want to use at runtime. So for example, when you do a .NET restore or a .NET publish, those commands need the SDK.NET base image. It needs the SDK tools. There's a much lighter .NET runtime base image, but that lighter image can't actually build your application as part of the Docker build. And this was really complicated to solve before multi-stage Dockerfiles, but multi-stage Dockerfiles make this super simple. It allows you to have different sections in your Dockerfile, each with their own from command, and you can copy from a previous section with a copy command. So you typically have two stages. The build stage would use your SDK base image with all the build tools in, which is a much larger image. And then the second stage would be based off the runtime base image, which doesn't have all the build tools and is much lighter weight. And you can just copy the built artifacts from the first stage into the second stage. And the resulting image at the end of the Docker build would be this second lightweight one that just contains your compiled files. So hard to explain over audio, so perhaps just take away from that there's this thing called multi-stage Dockerfiles that you should really know, and perhaps look at a few examples in the docs. But I did want to make sure that I covered multi-stage Dockerfiles just so you know they exist, as they are quite an important concept. Right, okay, so next up, I'm just going to talk a little bit about container orchestrators. It's mostly out of scope of this Docker episode. But basically, when running containers in production, there's a lot to think about. How do we handle traffic routing, health monitoring, scaling out, zero downtime when deploying, resiliency if the host goes down, and lots of other things as well. And this is where you'd use a container orchestrator tool like Kubernetes. There's a few different other ones, but Kubernetes has pretty much won the container orchestration battle in the same way that Git has won the source control battle. You still build the images in the same way as I described earlier. It would just be that your container orchestration platform would then pull those images down from the container registry in the same way, and it would create containers from that image and manage them for you. So it's the same kind of pattern. A container orchestrator just does a lot of the extra stuff that you need in production. So for local development, I must admit I personally don't use Docker for locally developing the actual service I'm working on, because I honestly don't see the value in it. I generally work with .NET. I've got .NET installed on my machine. I can just use it natively. I don't need to use Docker for this. I think some other languages that maybe that language doesn't work that well in Windows or something, then there's things like dev containers and various things, but I've not used those. I should really have a play. If you're a .NET developer, I've got to say, I don't really see the value in the service you're currently working on, you're currently developing, using Docker for that. But as I mentioned earlier, for local development, where I would use Docker is for running third-party services like SQL Server, RabbitMQ, Azurite, and so on. Each of my projects has a Docker Compose file in the project in source control, which has whatever dependencies that project uses. Then one single Docker Compose up command can spin them all up. It really is magic. And if I'm working on a project that has lots of different services, maybe a microservice kind of architecture, then I might use Docker Compose or even Kubernetes locally to spin up all the other services. But I don't tend to use it for this service I'm actually working on. It's worth noting that when you spin up these other services using Docker Compose, the service I'm working on can still access them via the localhost hostname. So things that are running inside containers, like your other services or databases, and also the service you're working on at the moment, running in Rider or Visual Studio, they can play nicely together because it's all on the same network. So I think that's perhaps enough for this episode. If you're new to the concept of containers, then this has perhaps been a bit too much to take in one go. If this is the case, I'd recommend, as I mentioned at the start, go away and have a play with Docker locally. Just try different commands, run different images, just play around. Then come back and re-listen, and hopefully it'll start to click then. As I said before, it's really worth making an investment learning Docker. There are so many different use cases, and hopefully this episode has helped a little bit along that journey. As usual, before I finish, a very quick dev tip. Very recently I saw an article that apparently they're now adding an argument to the .NET publish command that can tell it to output a built image. So I'll make sure that I include a link to that in the show notes, that article. And lastly, a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter @Drakan, and my DMs are open. And my blog, danclarke.com, has links to all my social stuff too. And I will include links to all the things I've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.